Hi everyone, in today's session we are going to be discussing the topic clocks. So first we will discuss the basics from this topic clocks, and then we will move on to solving questions from this topic. Coming to the types of questions that you can expect from the topic clocks, there are mainly three types of questions that appear in exams. The first type involves finding out the angle between the hands of the clock. For example, is given the time is 4:20. What is the angle between the hour hand and the minute hand? So this is the first type of questions that come from this topic. The second type involves questions wherein you are given the angle and you are asked to find out the respective time. Like for example, between 3 o'clock and 4 o'clock, at what time is the angle between the hour hand and the minute hand 30 degrees? This is the second type of questions that generally come. Now, the third type of question involves clocks which gain or loses time. So before we move on to these types, let us first discuss a few basics that you need to know from this topic, and then we will start solving the questions from each of these types. I hope all of you know how we represent time. Time is represented in terms of hours, minutes and seconds. So 60 seconds make up 1 minute, 60 minutes make up 1 hour, and there are 24 hours in a day. So let me share my screen first. We all know that a clock has two major hands, the hour hand and the minute hand. Now what does the hour hand do? The hour hand indicates time in terms of hours, and the minute hand indicates time in terms of minutes. Like for example, the time shown in the clock here right now is 3:05, correct? See, the hour hand, the smaller hand is the hour hand, it represents the hours, and the bigger hand is the minute hand and it represents minutes. We can say that a clock is divided into 60 equal parts, or we can say that the phase or the dial of a clock is divided into 60 equal parts called as minute spaces. Okay, that is, the circumference of a clock is divided into 60 equal parts called as minute spaces. In 1 hour's time, if you look at the minute hand, what does the minute hand do? The minute hand will start from 12, then it will complete one full circle and come back to 12. Or I can say that in 1 hour's time, the minute hand covers 60 minute spaces. Now, in the same 1 hour, the hour hand will cover how many minute spaces? It will cover only 5 minute spaces. Like for example, if the time is 1 o'clock and then it is going to become 2 o'clock, how much distance will the hour hand cover? See, it covers from here till here. That's all, right? See, this full clock has how many markings? 12 markings which are equally spaced, and we just said that this full circumference of the clock can be considered as 60 minute spaces. So this distance is how many minute spaces? 60 divided by 12, that is 5 minute spaces. So I can say that in 1 hour the hour hand will cover 5 minute spaces. So this is one way to look at it. The other way to look at it is by considering the angle in the clock. Now if you consider a clock, the full circumference of the clock is equal to 360 degrees, or I can say that in 1 hour the minute hand is covering 360 degrees, that is, it is completing one full rotation. It is starting from 12 and getting back to 12. So it is completing one full rotation, or it is covering 360 degrees. In the same time, what is the distance covered by the hour hand? The hour hand would have covered only, like for example, if the time is from 1 to 2, the hour hand is covering so much distance, or that is nothing but 360 divided by 12, which is equal to 30 degrees. So in 1 hour's time, when the minute hand covers 360 degrees, the hour hand is covering only 30 degrees. So that is what I have just written down here. See, in 1 hour the minute hand covers 360 degree or 60 minute spaces. In 1 hour the hour hand covers 30 degree or 5 minute spaces. And we can also say that in 1 hour, or that is in 60 minutes, the minute hand gains 55 minute spaces over the hour hand. Or we can say that the minute hand moves 12 times as fast as the hour hand. Or I can say that the minute hand is 12 times faster than the hour hand. See, these concepts will be very useful for us when we are solving questions from this topic, clocks. The next thing that you need to know is that in every hour both the hands of the clock coincide once. Like for example, if the time is 2 o'clock, okay, from 2 o'clock to 3 o'clock, how many times will the hour hand and the minute hand coincide? They will coincide once, that is somewhere around 2:10, right? Somewhere around this time, both the hour hand and the minute hand will coincide. That is when the minute hand moves towards here, it overlaps with the hour hand, and this happens once before it becomes 3 o'clock. Similarly, if you consider any time, let us say you are considering 5 o'clock. Okay, if you are considering 5 o'clock, this is going to be the minute hand and this is going to be the hour hand. So the minute hand keeps moving, the hour hand also keeps moving. Before it reaches 6, somewhere at this point, the minute hand and the hour hand will coincide. So we can say that in every hour, both the hands of the clock coincide once. Similarly, the hands of the clock are in straight line, that is, both the hands point the opposite direction once every hour. Or the angle between the minute hand and the hour hand is 180 degree once in every hour. Like if you are taking the time between 3 o'clock to 4 o'clock. Yes, what will happen? See, somewhere around 3:45. How will the minute hand and the hour hand look? So the hour hand is going to be like this, the minute hand is going to be somewhere like this, somewhat like this. Yeah, somewhere close to 3:50. Both the hands of the clock are going to be opposite to each other, or this angle is going to be 180 degrees. Next, the hands are at right angle twice in every hour. So what does that mean? Both the hands of the clock are perpendicular to each other, or the angles between the hands of the clock is 90 degree twice in every hour. How do you explain that? For example, if I am taking the time from 3 o'clock to 4 o'clock. Again, see, at 3 o'clock itself, how is the hands of the clock? It is perpendicular to each other. Now, somewhere around 3:35, yes, so the our hand is going to be like this and the minute hand is going to be like this. At this point also, the angle is going to be 90 degrees. So in every hour, the hands are at right angles twice, and the hands are in a straight line, or basically the angle between the hands is 180 degree once in every hour, and both the hands of the clock coincide once in every hour. That is, the angle between the hands of the clock is 0 degree. Okay, now these are very basic things that you need to keep in mind, because sometimes questions are based on these. That's why I am explaining all these concepts to you. Let us now look at questions from clocks wherein you are asked to find out the angle between the hands of the clock. So how will we find the angle between the hands of the clock? See, in this given clock, what is the time shown? The time shown is 1:15. Now we have to find out what is the angle between the hands of the clock. How will you find it? What is the normal way in which you will find the angle? See, now from 1 o'clock to 2 o'clock, if you look at the hour hand, what is the angle that is covered by the hour hand in 1 hour? We know that in 1 hour, the hour hand will cover how many degrees? 30 degrees. Yes, or I can say in 60 minutes, right, the hour hand will cover 30 degrees. Or in 5 minutes, what is the angle covered by the hour hand? The hour hand will cover 30 into 5 by 60, or that is equal to 2.5 degrees. Yes, so every 5 minutes the hour hand will cover 2.5 degrees. Now what is the time here? The time here is 1:15. So when it was 1 o'clock, the hour hand was here. Now in this 15 minutes time, what is the angle that is covered by the hour hand? The angle that is covered by the hour hand is nothing but 2.5 into 3. See, every 5 minutes it is covering 2.5 degrees. So in 15 minutes the hour hand would have covered 2.5 into 3, which is equal to 7.5 degrees. Now what are they asking us to find? You have to find this angle. Now see, if the hour hand has already covered 7.5 degrees, what is the angle that is left by the hour hand to cover here? See, this full degree. Yes, that is, see, from 1 to 2 we know this angle is 30 degrees. In this 30 degrees, the hour hand has covered how many degrees? 7.5 degrees. So how much is remaining here? 30 minus 7.5, that is 22.5 degrees is remaining here. So this angle is 22.5. Now what is the angle between 2 and 3? That we know as 30 degrees. So at the time 1:15, what is the angle between the hands of the clock? It is nothing but 22.5 plus 30, that is equal to 52.5 degrees. So this is how you calculate the angle between the hands of the clock at any given time. Okay, so how did we calculate it? See, first we find out, see the given time is 1:15. So first we find out what is the angle that has been travelled by the hour hand from 1 o'clock till 1:15, and what is the remaining angle that the hour hand has to cover. So the hour hand has reached here already. We have to find out the remaining angle that the hour hand has to cover to reach till 2. Once you get this, you know the angle between 2 and 3 is 30 degrees. So add these two, that will be the angle between the hands of the clock at 1:15. So this method, even though it is not very difficult, it is a time consuming method. So there is a shortcut which you can use to solve such questions, especially in examinations. We might not have the time to sit and do these calculations. So there is a formula which you can memorize. If you memorize this formula, it will be very easy for you to solve questions of this type. Now let us look at the formula. So this is the formula. What does the formula say? The angle between the hands of the clock theta is given by 30h minus 11 by 2m, where h represents the hours and m represents the minutes. Or I can say theta is equal to 11 by 2m minus 30h, again where m represents the minutes and h represents the hours. Now what is the difference between these two formulas? See, whenever you are given a particular time, in that particular time, if the minute hand is behind the hour hand, then you have to use this formula. If the minute hand is ahead of the hour hand, then you have to use this formula. Like for example, if I am considering the time 1:15. So at time 1:15, where is the minute hand and where is the hour hand? See, this is going to be your hour hand and this is going to be your minute hand. Or I can say that the minute hand is ahead of the hour hand. So if the minute hand is ahead of the hour hand, which is the formula that you have to use to find the angles between the hands of the clock? The second formula. So let us try to apply this formula here and see what answer we are getting. So the angle between the hands of the clock is nothing but 11 by 2m minus 30h, where m represents the minutes, that is 11 by 2 into 15 minus 30 into h represents the hour, so 1 o'clock, so 1. So what do you get here? 165 divided by 2 minus 30, or that is equal to 82.5 minus 30, which is equal to 52.5. So this is how you calculate the angle between the hands of the clock using the formula method. So depending on whether the minute hand is behind the hour hand or the minute hand is ahead of the hour hand, you can use the formula accordingly and get the answer in one step. I hope it is clear. Now let us look at a question wherein we have to calculate the angle between the hands of the clock. What does this question say? What is the angle between the hands of the clock at 4:20? So what is the time here? The time here is 4:20. So at time 4:20, how will the minute hand and the hour hand be? So how will the hour hand and minute hand be at 4:20? This is going to be your minute hand and the hour hand is going to be ahead of the minute hand. So what is the formula that we have to use here to find the angle between the hands of the clock? Here the minute hand is behind the hour hand, or the formula that we have to use to find the angle between the hands of the clock is nothing but 30h minus 11 by 2m. This is the angle theta, or here put in the values 30 into 4 minus 11 by 2 into 20, or that is equal to 120 minus 110, which is equal to 10 degrees. So the answer for this question is option B, 10 degrees. At what time between 6 and 7 are the hands of the clock 5 minutes apart? So how do we solve this question? See, first let us find out what 5 minutes apart means. Now 5 minutes apart means the hour hand and the minute hand are 5 minute spaces apart. In the beginning we discussed that the complete dial of a clock can be considered to be divided into 60 equal parts called as minute spaces, right? Or a full circumference of a clock has 60 minute spaces. Now between the two hands of the clock we have 5-minute spaces. Or what is the angle that is there between the hands of the clock now? It is nothing but 30 degrees. How do I say 30 degrees? See, the full clock is divided into 360 degrees, or that is equivalent to 60-minute spaces. So how many degrees does 5-minute spaces represent? 5-minute spaces represent 30 degrees, or I can say that the angle between the hour hand and the minute hand is 30 degrees. Now, if I say the angle between the hour hand and the minute hand is 30 degrees, between time 6 and 7, there are two possibilities that can come. So the time is between 6 and 7 here. So one possibility is the hour hand is somewhere here and the minute hand is somewhere here. Now this angle will be 30 degree. The second possibility is where the hour hand is somewhere here and the minute hand is somewhere here. Again you will have another 30 degree. So there will be two times between 6 o'clock and 7 o'clock when the angle between the hands of the clock is 30 degree. So you have to find both of these times and check with the options as to which is the correct options. See, somewhere around 6:40, around that time the angle between the hands of the clock will be 30 degrees, and similarly, and somewhere around 6:25 the angle between the hands of the clock is going to be 30 degrees. So let us try to find out both these. So there are two cases, right? The first case is this one. Let us take this as the first case, that is when the minute hand is behind the hour hand. So the minute hand is behind the hour hand means what is the formula to calculate the angle between the hands of the clock? It is nothing but theta is equal to 30h minus 11 by 2m, or that is equal to, here you have 30 into h you know is already 6, correct? See, time is between 6 o'clock and 7 o'clock, so time in terms of hours is 6, minus we don't know how many minutes after 6 o'clock is this angle 30 degree. So I know the angle, I know the hours, and I just have to find out the minutes. So what is the minutes? 11 by 2m is equal to 30 into 6, that is 180 minus 30, or minutes is equal to 150 into 2 by 11. So 150 into 2 by 11, that is 300 by 11, or this is equal to 27 3 by 11 minutes past 6, right? Now 27 3 by 11 minutes past 6. This is the first case. Now next when will this angle between the hands of the clock be 30 degree? That is when the minute hand is ahead of the hour hand. So again in this case theta is equal to 11 by 2m minus 30h. So here I have theta as 30, that is equal to, I have to find out the minutes when this is happening, and h is 6. So when you solve for this, what will you get? You will get m is equal to 180 plus 30, that is 210 into 2 by 11, that is 420 by 11, which is equal to 38 2 by 11 minutes. So in both of these times, right, that is 27 3 by 11 minutes past 6 and 38 2 by 11 minutes past 6, the angle between the hands of the clock is going to be 30 degrees. So if you look at the options, the correct answer that we are looking at is option C, both A and B. Both of these are correct. At what time between 3 o'clock and 4 o'clock will the hands of the clock be together? So what are they asking here? They are asking when will the hands of the clock be together between 3 o'clock and 4 o'clock. Together means the angle between the hands of the clock is nothing but 0 degree. Hands of the clock are together means the angle between the hands of the clock is 0 degree. When will that happen? So if we apply if we use the formula that we have learned, what is the formula that we have learned? We know theta is equal to 30h minus 11 by 2m. If the minute hand is behind the hour hand, or I can say theta is equal to 11 by 2m minus 30h if the minute hand is ahead of the hour hand. Whichever be the case, here theta is 0 degree, or if theta is 0, what does that mean? I can say 30h is equal to 11 by 2m. So whenever theta is given as 0 degree, you can directly say that 30 into h is equal to 11 by 2m. So here what is the value of h? H is 3, right? Because they are asking between 3 o'clock and 4 o'clock, when will the hands of the clock be together? So I just have to find out what is the value of m. What is m here? 30 into 3, that is equal to 11 by 2m, or m is equal to 30 into 3 into, that is 90 into 2, which is equal to 180 by 11. So the minutes is nothing but 180 by 11 minutes past 3 o'clock. So which is the correct answer here, answer option? 180 by 11 is nothing but 16/4 by 11. That is option C. So always remember, whenever theta is equal to 0 degree, I can say 30h is equal to 11 by 2m. And you have to just put in the values and arrive at the answer. Next one. At what time between 6 and 7 will the hands of the clock be perpendicular? So how do we solve this question? See, between 6 o'clock and 7 o'clock, there will be 2 times when the hands of the clock will be perpendicular to each other. If I take this as 12, 6, 3 and 9. So somewhere around 6:15, right? Somewhere around 6:15, the angle between the hands of the clock will be, somewhere around 6:15, the angle between the hands of the clock will be 90 degree. Not exactly 6:15, somewhere near 6:15, like 18 minutes, 6:18 or something, yeah? So at this point, the angle between the hands of the clock will be 90 degree. See, there will be one more time between 6 o'clock and 7 o'clock when the angle between the hands of the clock will be 90 degree. That is somewhere here, right? See, when this is going to be your hour hand and your minute hand will be somewhere here. So at this point also, the angle between the hands of the clock would be 90 degree. Okay, so there are 2 times between 6 o'clock and 7 o'clock when the angle between the hands of the clock will be 90 degree. One time is around 6:15, the other time is around 6:45. So we have to find out the time. Now, for this question, so generally how will we do it? See, we know there are 2 formulas, right? Theta is equal to 30h minus 11 by 2m. So using this, you can find the angle between the hour hand and the minute hand when the minute hand is behind the hour hand. Similarly, you can say theta is equal to 11 by 2m minus 30h. Now this is when the minute hand is ahead of the hour hand. So both of these formulas you can use and find out both these angles, right? Both these timings, at what time the angle between the hands of the clock is perpendicular. But here, if you look at the options, see, as I said, one time that we are looking at when the angles will be perpendicular to each other is around 6:15. Let's say it might be 6:17, 6:18, whatever. The other time is after 6:30, basically around 6:45. Now, if you look at the options very clearly, you can see that this is the angle that they are looking for, because all the options are like that, right? 49 1 by 11, 57 1 by 11, 47 1 by 11, 41 1 by 11. Basically, all the timings or the minutes that is given here is after 6:30. So you have to find out only this angle. So what is the formula that you will have to use? So when I have to find out this angle, I can see that the minute hand is ahead of the hour hand. So if the minute hand is ahead of the hour hand, which is the formula that you use? This formula. So what will you get? Theta is equal to, now I know theta is already equal to 90 degree, which is equal to 11 by 2m minus 30 into 60, or what can you say? You can say 11 by 2m is equal to 180 plus 90, that is 270, or m is equal to 540 by 11, which is equal to 49 1 by 11. So I can say that 49 1 by 11 minutes past 6, the angle between the hands of the clock will be perpendicular to each other. The correct answer that we are looking here is option A, 49 1 by 11. Remember, you should not waste your time finding out this angle. Look at the options very clearly. You can see that this is the angle that they are referring to. So you just need to find out this one value. A digital wristwatch was set accurately at 8:30 a.m. and then lost 2 seconds every 5 minutes. What time was indicated on the watch at 6:30 p.m. of the same day if the watch operated continuously till that time? How will we approach this? What is happening here? See, the digital wristwatch is set accurately at 8:30 a.m. and for every 5 minutes it is losing 2 seconds. So in 1 hour, how many minutes are there? In 1 hour we have 60 minutes. So in this 60 minutes, how many seconds will the watch lose? See, for every 5 minutes it is losing 2 seconds. So for 60 minutes, how many seconds will the watch lose? For 60 minutes, the watch will lose 60 into 2 by 5, or I can say it will lose 24 seconds. Okay, in 60 minutes the watch will end up losing 24 seconds. Now from 8:30 a.m. to 6:30 p.m. what is the time difference? See, what are they asking? They are asking what time was indicated on the watch at 6:30 p.m. on the same day. So from 8:30 a.m. in the morning to 6:30 p.m. in the evening, what is the time difference? It is 10 hours, right? In this 10 hours time, how much time will the watch lose? See, in 60 minutes or in 1 hour, I can say the watch is losing 24 seconds. So in 10 hours, how much time will the watch lose? It will lose 240 seconds. Now what is 240 seconds in terms of minutes? It is nothing but 240 divided by 60, which is equal to 4 minutes. Or I can say that in 10 hours, the watch would have lost 4 minutes. So when the actual time is 6:30, what will be the time that the watch will show? The watch will show it as 6:26 because it has lost 4 minutes, right? So it will be behind by 4 minutes. So when the actual time is 6:30 p.m., it will show 6:26. The correct answer for this question is option E, 6:26 p.m. A clock loses 5 minutes for every hour and another gains 5 minutes every hour. If they are set correct at 10 a.m. on Monday, then when will they be 12 hours apart? So this question is based on clocks which gain or lose time. How will we approach such questions? What is given here? A clock loses 5 minutes for every hour. Another clock gains 5 minutes for every hour. Okay, and it is given both the clock are set correct at 10 a.m. Okay, so we have two clocks. Let's take it as clock 1 and clock 2. So at 10 a.m. both of them are showing the same time, 10 a.m. correct, 10. They are set correct at this time. Now what is happening? The first clock, right? So this is your actual time. Actual time now is 10 a.m. and both the clocks are set at 10 a.m. The first clock is losing 5 minutes for every hour. So when the actual time is 11 a.m., what will be the time shown by clock 1? It will be at 10:55. Similarly, when the actual time is 11 a.m., what will the clock 2 show? It will show 11:05. Basically, it is gaining 5 minutes every hour. This is losing 5 minutes every hour. Similarly, when the actual time is 12, what will clock 1 show? Again, so again it will lose 5 minutes in the next 1 hour, correct? Or when the actual time is 12, clock 1 will show the time as 11:50. Clock 2 has to gain 5 minutes in every hour. So when the actual time is 12, what time will clock 2 show? It will show 12:10. See, every hour this clock is losing 5 minutes. So in the first 1 hour it has lost 5 minutes. So in the next 1 hour it will lose again another 5 minutes. So it will not show 11:55, right? It will show 11:50 because it is losing again another 5 minutes. That is, it is going behind by another 5 minutes. Here it is gaining 5 minutes after every hour. So this is how the timing between the clocks will be. Now let us say if the time is actually 11 a.m. 12 p.m. right? 12 p.m. Now if the time is actually 1 p.m. Now what will this clock show? It will actually show 12:45 and this will show 1:15. So if you see the difference between the time of both the clocks, if you look at 11 a.m., what is the difference between the time in both the clocks? See, the difference is here it is showing 10:55, here it is showing 11:05. So the difference is of 10 minutes, right? Now from 11:50 to 12:10, what is the difference between the time shown by both the clocks? It is 20 minutes. Here the difference between the time shown by both the clocks is 30 minutes. So basically the difference in the time between both the clocks is increasing by multiples of 10 in each step. So next will be 40 minutes, yes, then 50 minutes, then 60 minutes, that is 60 minutes is 1 hour. Or what can I say? For every 6 hours, okay, for every 6 hours, the difference in the timing shown by the clocks will be increased by 1 hour, right? See, for the first 6 hours, if you see, after this first 6 hours is over, the difference in the time shown by both the clocks is 1 hour. Then again after another 6 hours, the difference will again increase by 1 hour, or totally the difference between the time shown by the clock will be 2 hours and so on. Yeah, first for every 6 hours, the difference between the time shown by the clock will be 1 hour. Then for every next 6 hours, that is at the end of 12 hours, the difference between the time shown by the clocks will be 2 hours and so on. Now what is the question? What are they asking? If they are set correct at 10 a.m. on Monday, then when will they be 12 hours apart? Or when will be the difference between the times shown by the clock be 12 hours? That is what you have to find out. So how will you do that? So when, see, for every 6 hours, the difference is increasing by 1 hour and so on. So when will it be 12 hours apart? 6 into 12, that is 6 into 12 is 72. That is, after 72 hours, the difference between the time shown by the clocks will be 12 hours, or I can say that the clocks will be 12 hours apart. So 12 hours, that is 72 hours after 10 a.m. on Monday is when? See, 72 hours is equivalent to 3 days, correct? 24 hours make 1 day. So 24 plus 24 plus 24 is 72. So I am setting the clock right on Monday morning. So Tuesday morning, Wednesday morning, Thursday morning. So the clocks will be 12 hours apart on Thursday morning at 10 a.m. The correct answer here is option B, 10 a.m. Let us look at this question now. In this question, what are they asking? They are asking, the minute hand of a clock overtakes the hour hand at intervals of 65 minutes. How much in a day does the clock gain or lose? So whenever you have questions wherein they are telling us that the minute hand is overtaking the hour hand in an interval of certain number of minutes, and they ask us how much does the clock gain or lose in a day. For questions of this type, you can make use of a formula which will help you arrive at the answer faster. So the formula is as follows. If the minute hand of the clock overtakes the hour hand at intervals of m minutes of correct time, the clock gains or loses in a day by 720 by 11 minus m into 60 into 24 by m minutes. So if you remember this formula, solving such questions will become very easy. So what are they saying here? In the question given here, they are saying that the minute hand of the clock overtakes the hour hand at intervals of 65 minutes. So what is the value of m here? M is nothing but 65. Just substitute that in this. What will you get? 720 by 11 minus 65 into 60 into 24 by 65, or that is nothing but 5 by 11 into 12 into 24 by 13, which is equal to 1440 by 143, which is equal to 10 by 143 minutes. Now the answer that we get, okay, when we apply this formula, if the answer that we get is positive, that means that the clock gains, okay, time in a day. So here what are they asking? How much in a day does the clock gain or lose? So remember, whenever you are using this formula, if the answer is positive, that means that the clock gains. If the answer is negative, that means that the clock loses. So in this case, I am getting the answer as positive. So that means that the clock is gaining, right? So the correct answer here will be 10 by 143 minutes gain. Option A is your correct answer. Whenever you have questions wherein they are asking that the minute hand is overtaking the hour hand by certain number of minutes, so if you are asked to find out how much in the day does the clock gain or lose, directly you can make use of this formula and arrive at the answer.